I always said less than 7. And this is greater than. So six. What do you get if you use the button on your calculator? I'm not going to go any further than that because I'm just trying to show the process. Sorry? No, it ain't 7.02. That's 2. I'm saying that's 2.65. 2.645, and you'd run up to what we got, 2.65. Yeah. All right. So we're gonna extend that process of an error a little bit further, and actually there's indeed Nov Roots method. If you're going to do you might spread in Excel. Right, but you can see what you've got. Certainly the bisection method will. One appears to be much quicker. You can only use it if you can differentiate the function that you've got. So, in terms of trying to find the roots of an equation, both these two methods require you to make an informed first estimate. Okay? And there are two ways to do that. Either you can, one way is to look at a graph. So if you can graph the function, you can get a rough idea where the roots are. So if I take this function here, y roots, one there and one there. Okay, and the value of x is somewhere between 2 and 4, and somewhere between -2 and... We've got 2 roots there. All right. More advanced plotting software probably be able to point out anyway and identify them, but that's besides the point. All right. The other way is to take that function and put a value of x in, okay, and look for a change of sign. Negative there. Look for change of sign, then we can find out our estimate of where the root is. In this case, if we say x is equal to 2, we get a result for that function of -3 down here. And if we put x is equal to 3, we get a value of 1 up there somewhere. So we now know that there's a root in that function between the values of x is equal to 2 and x is equal. So that's our first estimate, is that we've got a root between. So, looking at a full example of how this process works. To find the positive root of the equation 5x squared plus 11x minus 17 is equal to 0, we're going to find it correct for 3 significant digits. Okay? So there's our function. Okay, if we put the value x is equal of -1, and if we put the value, we get an answer of +25. So there's a change of sign. The root of this equation, the positive root, x is equal to 2. You all understand that because of that. And graph. So that's the first between the two limit values. Equal to 2. So formally, we find So we this now between and 1.5. Two five. One plus 1.25. $1.125. All right. What I'm going to do here is start rounding this. This is our new guess for the root. We want to start rounding that to 3 significant figures over here. 1.13, and that'll be. We're going to use that value. That's 3 at the end. So we put that value in the function. The function at 1.125 is equal to 5 times 1.125 squared plus 11 times 1.125, 17. And I believe if you calculate that, that is equal to plus 1.0312. Yeah. It's still positive. Therefore, the root lies between 1.5. No, that's not that you round to the 3 decimal places. It's the estimate. That's that value. Now I'm going to put in that formula 1 3 decimal places. All right? Yeah? So that process on. What you'll at twice in a row, 3 decimal. Okay? So carry that process through, please.